turn to page 232 in your textbook, page 232. I want to preview a chapter that is going to totally change pace on what we've been doing. And that is talking about area, volume, a lot more math, a lot more formulas, whereas what we've been doing, Lana, had been a lot more facts about different things. This is going to be more, let's actually calculate some different things. First of all, I want to mention what area is. It's the amount of stuff inside any closed figure. So, no matter how weird it looks, however much stuff is inside, that's the area of the figure, okay? Now, for the most part, we're going to be working, though, with polygons, figures bounded by straight lines. And so the idea would be breaking this thing down into tiny little square units, little square boxes. Well, the easiest shape to do that with, of course, would be a rectangle. And you see that there on page 232, that orange rectangle right under that blue bar that says area. And you see there that for a rectangle, it easily breaks into nice, easy units. Break it down into, notice, 7 individual units going across the bottom, 4 individual units going up the side, where if you wanted to take time to count it, you'd count 28 boxes. But we're too lazy, right? We know that 7 by 4 would equal 28. Important to notice, circle the words square units after where it says 28. Area is always measured in square units. So if units are inches by inches, that's square inches. Feet by feet would be square feet. So very straightforward for a rectangle to calculate area. Area equals the number of units across the base times the number of units up the height. Or sometimes you'll hear these referred to as a length and a width of the rectangle. So base times height would give us the area of our rectangle. For a square, you notice in the table down below, well, a square is a rectangle, isn't it? But the base and the height happen to be the same length. So we could refer to the base as just a side, in which case the height would be the same side. So the area of a square would be the length of a side times the length of the other side, or we could say side squared. And you see that area formula there. A parallelogram, as you may recall from years gone by, is basically a slanted rectangle. You could cut off, notice, a little piece of rectangle, or a little piece of parallelogram, the angled part, and move it to the other side to turn it into a rectangle. So therefore, a parallelogram has the exact same area formula as the rectangle does. You look at the top of the next page, a triangle. If you were to duplicate and flip it, notice the dotted green triangle at the top of the next page? Well, that's congruent to the original triangle. A triangle is exactly half of a parallelogram that has the same base as the triangle and the same height as the triangle. So a triangle then, because it is essentially half a parallelogram, the area of a triangle would be a half. Base times altitude, stay with me for just a moment longer. And then the trapezoid, finally, is a little bit weirder. Notice how they take the trapezoid and they divide it with a diagonal line into the dark green and light green triangles. Well, both triangles have the same height, but they have different bases. So since the area would be, well, a half base height of this triangle plus a half base height of that triangle, the area of the trapezoid is 1/2 the height times the sum of the two bases together. And these 5 area formulas you need to have memorized. Now the good news, Lana and Josh and Scott, is that you should have already memorized these formulas in the past. But make note of them. You're going to use these area formulas tonight for homework. Look over with me at what we're going to do for homework. It's on page 238. You're going to do pages 238 to 239, the homework 1 through 15. Now, we didn't have enough time because of the quiz to practice much of in fact, any of this in class. So just do your best on the homework. If something confuses you, just do your best. And we'll go over it in our next lesson and make sure we're good to go there. But your homework, page 238 to 239, the homework, doing just numbers 1 through 15. Then tomorrow, we'll go over the homework and we'll actually have a chance to practice in class, making sure that we're good to go with these formulas. All right, you are dismissed. Have a wonderful rest of your day.